have it in, let me see if I can do this quickly. 1, 2, and 10. Okay. One second. 10. All right, now I'm going to go, and it was what? 10:70, 11:45. Okay, so once I have my data, I have to remember if I, oh, I'm sorry, I thought you could see that. You need to remember that I want to see if my second plot is on, my second plot is off, so I need to do what? I need to enter, I want to make sure that it's on, okay? And I think they even told you what window to do. So the window was, I ended up changing the window. I think I'm going to leave it at -1. I told you, I like to be able to see the whole thing. And I went up to, I think, 25. My scale was 2. They said a Y minimum of 1,000. I think I again did a 0. And I did a max of 3,000. And they did a scale of 1,000 and graph. Oops, I have an error in here. Drafts. 0. All right. I thought I did. If I go to 20, I'm just going to do this quick now. 1,000. That should work. I'm getting an error.
Your data, maybe? If there's something wrong with your list?
Yeah. Just go. That's all. 1,000, let me just check my numbers. 11:45, 12, 13, 14, 15, 16, 17, 18, 19. No, that should have been okay.
Then your staff plot? No, you don't.
No, I did that.
Check your, where it says stat, your plot thing, did it actually turn on?
Oh, maybe you're right, you're right. It's on, no? Okay, can we use somebody else's, because, is yours on? Do you have that on there? Yeah. Okay. My data didn't look like that.
Look at Matt.
Can I just see, let me just see, Matt, that you're, I did this, yeah, did you do my window I had suggested?
I think so, I don't know if I put it 20 or 25, but.
Yeah, you did 25.
Okay.
Okay, so his is slightly different, so we'll compare graphs. Okay, so your graph, whatever your graph is it a straight line? Okay, and that's all that you need to know, that data in the real world is never just going to be a straight line. It would be nice if life was just so regular, but that's not the case. So in this particular case, you could see that you have a curve. Okay, so from there, let's go on. So we're now going to do a power regression. Okay, remember when we tried to find the line of best fit, we were using a linear regression. Well, this is a power regression. Why do you think it's going to be a power regression?
It's not a straight line.
It's not going to be a straight line, and we've been doing what? 9 to the 1/2, or 9 squared to the 1/3. We're using a power, we're raising a number to a power, and the graph is not necessarily going to be a straight line. So, in this case, let me see, I remember how to do this. All right, so I'm going to go back to Stat. I'm going to go to Calc. You see that? And here, I have to scroll all the way down to, down here, Power Regression. I hit Enter. And I have to hit Enter again. And so when you enter it twice, you will get this information. So it's taken your data and converted it into an equation, and you can see that you have 0.265 is 0.265 a rational number. Okay, so we have an exponent here that's not going to just be a linear equation, and it's not a quadratic. It is what we refer to as a rational exponent. Okay, so now if I want to see that graphed over the data, I go to vars. The vars button is right here. Oh, wait a minute, I have to go to y equals first. I'm going to go to y equals, because I want that equation in the want to graph. So now I'm going to vars. I'm going to 5, which is statistics. I'm scrolling over to EQ, which is my equation. And that is that was the numerical coefficient, I guess. Mine came out differently. I just need to see how this graph on my calculator looked differently. I don't know why.
What?
Did anybody get theirs to graph theirs? I don't know why yours didn't do that.
I got it to graph, I don't know if it's right.
Did it cover the dots?
Well, some of them.
Yeah, okay, some of them, there you go. Okay.
I just have
And
to
I
enter-
couldn't get
I
that
just have to
in.
enter the,
Okay, can I use that? All right, thank you. Okay, now remember, it's kind of like a trend line. If you have data, this is approximating the data. And in this particular case, I believe they were saying the storyline was that in 10 years, it would double. So let's hit trace and see. All right, so when x is 1, I'm right here. Okay, so when x is 1, and could I do, and I could go trace, but I could do an easier way. I'm going to say a value when x is 10. Okay, so when x is 10, they're going to tell me what my value should be, and it would be 1791. Did it, in fact, double in 10 years? No, didn't. Okay, they told me it would, but it didn't. So let's go back and I'm going to hit clear, and let's go to trace. And I'm going to say, well, how many years will it take to get my thing going? No, it's not doing that. Hold on a second here. I'm going to punch in, actually, I don't know. Why can't I trace?
because it's tracing the dots.
Yeah, it's tracing the dots, that's right. I needed to be on the other one, there it is. On the right one. So now I am looking to see, well, in 12.5 years, I'm at, what, $1,900. Oh, right about there. So in about how many years will it be before, in fact, it does double?
But if it started at 1,070, wouldn't it be like
It started at
2,100?
It started at 1,000, or, at 1,070, you're right. So, I'm sorry, what?
So it's like, it's further along the line.
Okay, because I'm doubling 1,070, right. Okay, so it will be,
No, you only started with 1,000, but one is what you
How
have
many
after
years
a
have
year.
passed?
So once 1 year has passed, if you invested 1,000, you have 1,070.
right.
So
Oh, okay, that's right, sorry, that if you had advertised. So this is after 1 year. This is the investment after a year.
Okay.
Okay? You're right. Okay, so that's just an idea of, again, an application for you. All right, so the time is ticking and I have some other notes that I want you to do. Okay, so is everybody okay with that? The idea? All right, notes. These are going to be radical equations. So whose is this?